Hello, good morning, good afternoon. Let's get back to work. I have to refresh what I've done, what I did last week, and to check what's on the list for today. And the message for my future self is here. Clock is about 33.4. Let's check it if it's true and identify and locate the clock. Should be this. Yes. 34.4. It's valid. 34. I said 33. 34.4. Yeah, it's not valid. Yeah, never mind. And check which signals of the AC signals can be bit swapped. Okay, that's really important. So let's work on that. And I think I will need the STM Cube MX again, because I think it's the easiest way. There is the signal, how to say, configurator or arbiter, I don't know. No, download. Cancel. Oh, I won't just start new project. -3, that's our thing. Start project, yes. Anyway, yes. This, and let's wait a sec until it's configured and ready. Now, the DDR3, yeah, this is the tool. Let's make it bigger. 3 is our technology or family or generation. Generation can be the right word. 16 bits is our data bus width, and I think 4 gigs. 4 gigs? I still don't know. It's 512 megabytes times 8 is 4,000 megabits. It means 4 gigabits. That's correct. And let's check the status. Yes, all AC signals are here. All AC signals, okay. And let's, yeah, the best way is to copy my current setup to the project of STM Cube MX. It will take a while, but it's the natural thing, because yeah, we just have to. I hope it will work this way, and it seems it will. So on the left side of the symbol, there are good morning, good afternoon. Yeah, thank you. I'm happy you like it. How are you? Okay, so A0 is CKE. Yes, yes, there are 7. These signals can't be relocated, and I finally have to make a note here. Relocated. I think relocated is the correct spelling. Relocated. If not, yes, probably yes, because there are some shared. What's this? Previously relocated items. What's that? That's some what are relocated. Okay. Interesting. Okay, I keep it open, and after the show I will check them. Yeah, every day is a new day to learn something new. Yeah, thank you. I'm doing fine. I'm doing excellent. Thank you. Let's get back to work. So, A0 to A7 can't be relocated. A8 is, yeah, I'm looking at the symbol, which is just a symbol. Now, A8 is BA1. Okay. A9 is A14. Yes. A10 is A1. A11 is A11. A12 is A0. A13 is A5. A14 is A7. A15 is BA0. A15 BA0. A16 is write enable. A17 is RASN. Or row access signal negative. A18 is A15. A19 is not connected. You can see that, or you can't see the A19 in the symbol. A20 is A8. A21 is A6. A22 is A4. A23 is A10. A24 is missing here. A25 is A12. A26 is A9. A27 is A2. A28 is A3. No, A2 is 27 A2. I made a mistake. A28 is A3, yes. A29 is CASN, or column access signal negative. A30 BA2. And finally, A31 is A13. And there must be a mistake because the checker says it's KO. So let's make a quick check again. A8 is BA1. Okay. BA1. I was wrong at the beginning. Yes, now it's okay. Probably I made a mistake at the very beginning. Okay, so this is our current state. Obviously, I can't save it because the tool is so intelligent that it doesn't work on my Mac, but what? Anyway, the question was if we can bit swap any or all of the AC signals. The answer is, or the question is tricky because I can't verify all combinations. But for instance, if I switch BA1 and 14, it works. In my opinion, I don't know the details of this checker, but in my opinion, in my humble opinion, this checker only verifies if all the signals are present and if there is no doubled or tripled signals, or as I said, if all are present, it means if any of them isn't missing. So I mean that all these signals, A0 to A15, yes, A0 to A15, BA 0, 1, and 2, write enable, CASN, RASN, and that's it, are or can be relocated, can be bit swapped. Yeah, this is what I can see. No, thank you. I'm not. Okay, so the question can be tricky, but the answer is yes. Probably unroute all of the purple AC signals. Yeah, that's not a question, that's a offensive requirement. But yeah, I take it. I take it easy because it's from my past myself, and I'm not offended by my past myself. Okay, so the next point, route A0 to A15, all the AC signals, matched to clock with ±3.5. Okay, now the clock is 34.4 and the purple signals are not routed anymore, but only segments of it. And yeah, I clearly, yes, I remember. I recall it from the last week. Yeah, I'm sorry for that because I'm not so fast. Now I'm on track. I'm back on track. Last time we rotated, I think, yeah, we rotated, or the week before anyway, and all the signals were routed like this, yeah, from bottom all the way to the top and then back to the MPU, which is not very effective and it makes all the signals really long. But if we route all of them like in a natural shape, like here, the similar way as the red ones, it means that the length can be much closer. I don't say that all the signals will be, I'm not saying that all the signals will be length matched to the clock, but because it won't, they won't, but will be much closer, because as you can see, this is the clock pair, and if we make them a little bit longer, so I will keep this area and probably here, I'm not sure with this area, but I want to say that I have to keep some space to make them longer, because for instance this is 29, this one is about 30, and there is quite a loose tolerance, plus minus 22. So from 34 we have, as you can see, tolerance between 12 and 56, which is fine. Data signals, but the AC signals are much stricter, much more restricted, let's say, and or limiting, because the matching must be plus minus 3.5. That will be tough, and I think to not pull all the burden of the incorrectly routed segments, I will follow this requirement, probably unroute all the power play signals. Yes, I will. Not these ones, because these ones are, let's say, correctly fanned out, but these ones. So let's make it quickly. Yeah, and I forget to start key screen. Now it's working. Yes. So this one, my heart hurts a little, because I spent quite a long time routing them, but not these ones. But as I said, the burden of incorrectly routed signals and the fact that all the routing is not optimal is much more or is much heavier to bear. Hello. So all of the purples are lost. Now, because the purple one, it means the inner two inner two layer is basically free. As you can see, there is nothing, just this part of the clock. I can make it longer a little bit, but we have some options. And now I want to make some floor planning. As we can see, all the AC signals or air wires or red's nest wires are colored in blue, and if I focus on them only, I can see our cat is getting crazy. As I can see that all of them is going downwards. So what's the optimal way where to start? We can start from the inside. like this. And then continue with all the other ones. Basically, half of them yeah, I'm thinking. I'm just thinking. I'm thinking that to, let's say, normalize their length, the track length, it would be smart to route all these signals coming from this segment, the bottom right segment, coming somewhere here, because the track would be shorter, and all the signals from here should be routed to the upper part, because yeah, there is the distance between these pads, which is about let me measure it, 5 millimeters, maybe 6. So yeah, that can make sense. And the same philosophy can be applied to each group. So the signal from the upper part, from the top, like this one, should be connected somewhere in the bottom, because the same distance difference is about 4 millimeters between this pad and between this pad and this pad, about 4 millimeters. And if I place them like the top one to the bottom and the bottom one to the top, it means that it should normalize the track length, but it inevitably would cause crossing. Yes. Because if I want to connect this one here, and the one from the bottom should go somewhere here, there is a crossing. So yeah, this philosophy shouldn't be applied to the group. It means that the philosophy should be or the workflow should be to connect the top one from here to the top of the group, and then each of the other ones should be below it, should go below, like in sequence. Okay, so now I have to know where should how many of them are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me mark it down, because I am pretty sure that I won't keep this info or intel in my head for longer than 30 seconds. So 10 I said, yes? 10 signals from the segment 2, let's say. I'm double checking it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's correct. And the segment 3, which is, let's say, this one. Yeah, I'm numbering the segments like 1, 2, 3, 4, like I don't know how, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, okay. No, I'm wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I stupid or not? I'm sorry. Yeah, anyway. Oh, okay, again. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What am I doing wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I don't know. 10, 11, 12, 13, 14, 15, 16. No, 8, 19 is not there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. Okay, must be 12 in here. No 10, I am... Okay, again. If all of them are present, because I I need to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So from the bottom, 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 of them. Yes. Yes. Okay. So Yeah. Thank you for the summary. Yeah, I'm using Gemini. What LLM model are you using? So we have to swap A10 and A9. And at the same time, no, but not here. No, here. Here. It would be basically the same, but I need to keep track of these signals because it's easy to use the configurator or the checker. So 9 and 10. Yes. Okay. At the moment, 35, which is a good number because we have to be, at the moment, roughly in between 31 and 38. Yeah, plus 7, 31 plus 7, 38. Okay, let's continue and we will see. I will keep the distance in between signals reasonable to be able to make some length tuning patterns afterwards, because I will most likely need it. A5 and A15. A5 and A15. Did I make the change or not? Yeah, I did. So A13, A15, and A18, A5. Okay, I'm double checking it on the way because it's so easy to lose a track and I'm not so focused because I'm talking and it distracts me. Now, probably this one. If I start with this one and it will go upper, it means it will be even longer. So no, this one. Maybe the distance between signals is too big. A2 and A12. A12 and A2. Swap, okay. And it is 25 is 2. And 27 is 12. Yes, okay. A3 and BA1. A3 and BA1. A3 and BA1. A20, A3 and BA1. Okay. Yes. What's the length? The moment 35 still within. Now we have to start with this one. Okay, I will keep this. No. This. Yes. Okay, I have to make more space here for the signals. Definitely not much length tuning will be happening in here. Yeah. Oh, I was thinking about that. 我每天都早上吃肉和面包，每天都喝奶茶，你呢？A0 and A1. A0, A1. Okay. Approved. What's the length? 36, it's getting longer. We have to cut some corners in here, but we can do this, and it effectively shorten the distance. Yeah, I would say significantly. BA0 and A4. BA0 and A4. Okay, approved. The length is 35, okay. Write enable and A11. Write enable and A11. A11. Okay. Okay, approved. Okay. CASN and A6. CASN and A6. Swap. CASN and A6, yeah. Yes, approved. Last two signals. Yes. RASN or RASN and A14. Swap. Okay, approved. And the last one, this one. BA2 and A8. BA2 and A8. Swap. Approved. Okay. Okay, so we have, let's say, draft routing of the segment 2 of the DDR3, and now we have to start with this segment. And now the question is where to start. If I go this way, like an example, we would get, let me take my machine, we would get 17.5 plus 4.8 roughly, about 5, 22. That's too short. Okay, that's too short, and we have to get at least extra 9 millimeters, which is impossible. If we go this way, we would get 31 plus, let's say 5, 36, or a little bit shorter than 36, which is good. We have tolerance band of 31 to 38. So we are in the upper half, which is which is not very convenient, but we will go, or the signal's location or starting points will grow lower, or will go lower, and it means that the distance will get shorter, because the distance between these signals is shorter than this, like 0.5 millimeter to 1.5, I think, millimeter is the distance of where the length of the signals will get. And I think this is a good start. So I will start in here, maybe with some cut corners, and then with these signals on the left, we will get some space to make some meanders. So yeah, I will do it. So CASN, thank you, my calculator, and A7. Okay, I lost my track a little, and now I lost my numbers. CASN and A7. Swap. Okay, approved. Nice. Another one is this one. Oh, come with me. WEN and A13. WEN and A13. Swap. A13 and WEN. Okay, approved. Yeah, 35, it's getting a little bit shorter. Yeah, now I will start with this one because I need to get a little bit shorter distance. BA0 and A9. A9 and yes, the neighboring signals. Here, A9 and below BA0. Okay, approved. What's the length? 34, yeah. We are getting good job, or doing good job. A5 and BA2. Hello, Wasi or Ali. Wasi, hi there. One basic question. I see some components is green. Yeah, we have to deal with it. We have 6-layer stack, and all these components are, yeah, as you said, on the bottom, and majority of them, like 95%, are the coupling capacitors. So definitely we will use the port ground plane on the bottom, plus we can share via if needed. So yeah, it won't be super convenient, but as you can see, here is the top layer component, and this is bottom layer. And the position of this component, you can say that I can't place via here, which is correct, but I can do with this component, for instance, this. Yeah. And now I have some space. So definitely it will affect the routing, but this DDR signal routing is definitely more important to this job. Yeah, I hope it answered your question. Another swap, A5 and BA2. A5 and BA2 neighboring as well. That's a nice coincidence. A5 and BA2. Okay, approved. That's nice. Okay. Okay, what's the length? Yeah. I don't want to say ideal, but close to optimal. A3 and A3 doesn't need to be swapped, which is the first signal out of 22. That doesn't need to be swapped. A0 and A2. A0 and A2. Can you see it? I don't. Here, A2, A0. So did I do that? Yes, I did. A2 and A0. Approved, okay. Yeah, we are getting shorter. 31, yeah. This is getting rather short, and we are at the bottom. Yeah, we are at the bottom, at the lower end of the interval, which is concerning. This is concerning, and it means that all the other signals will getting too short. So it means that I have to start with some length tuning miracles right now. Wait. What? Yeah. What are you doing? It seems that there is a, yeah, there is a DRC problem. Now it's solved. $31.4, yes. So if I do this, yeah, it's getting shorter naturally because of the Pythagoras triangle. yeah, I have to keep some space for Andres here. Yeah, definitely. Hello. Is the pin package delay included in the footprint library? Pin package delay. You mean probably something which is normal in other EDA tools? No, KiCad doesn't have a storage or nodes or rules for the pin package delay. You have to keep everything by yourself. So the answer is no, unfortunately. I don't know if I answered your question, but yeah, definitely not in the footprint library. No. Which pin package delay. Oh, I mean, I understand. You mean, yeah, you mean delay from the pad to the chip itself, the chip layer, like the bonding delay. Okay, no, unfortunately, no. Yeah, I'm lagging. The internet is lagging, but it's working. Yeah, back to the question. No, unfortunately not. And your question lead me to the to the datasheet of the DDRC module. Let's check it if there is something mentioned there. Okay, so let's start with delay, yes? No delay. Length. No, there is nothing like this. There is a following comment. Thank you. Probably yes. I don't use Altium Designer. In that perfect EDA tool, you usually specify the delay in picoseconds. Yes, the bonding. Thanks for the answer of the stream. Yeah, I love this as well. Thank you for being here. They introduced some feature of time tuning instead of length tuning into KiCad, which is something I haven't met yet. And let's check the internet. KiCad 10 is the first version of this, and time tuning track picosecond. I think they mentioned something like this. New features, high-speed tuning, yes. High-speed tuning, time domain tuning, they called, and what's this? Tuning profiles. Yeah, you can define tuning profiles, which is something I don't know what is this, but maybe you know. So signal layer from front to bottom, via layer from front to bottom, and there is a 70 picoseconds example number, which can be used in the net classes. Yeah, and each net class in the board setup. Tuning profiles is empty because I don't have one, and you can use tuning profile here. So you can make the board absolutely perfect, I think, but you have to manually edit this. And let me keep this open because I will take a look at it after the show. Yeah, definitely there are some powerful tools in the KiCad, but I think based on the requirements of the DDR3 routing, it's not the case of the DDR3L memory. But definitely if you are working with DDR4, 5, or even faster, definitely I recommend taking a look at it. Thank you. Let's get back to work. Yeah, I wanted to start with length tuning because this track is getting too short. Too freaking short. Let's start with this one. Let's continue with this one because I think this is not yeah, even this can work. So yeah, I have to keep at least half millimeter ballpark center to center of the track for the length tuning. Yeah, the troubles are coming, but okay. Thank you. Another question, comment, experience sharing. Thank you. That's always welcome. When I worked at National Semiconductor, I don't need to read it because you can by yourself. An acceptable picosecond timing window. Most chips worth their weight do this. Okay. Yeah, the question is how to get this information, because in the datasheet of the DDR3 memory, as we checked, I don't know, 3 minutes ago, there is nothing in there about that. Maybe it's some not publicly shared information, or maybe you have to sign some NDA. I don't know. Micron doesn't mention this in the datasheet. Yeah, maybe in the faster technology devices. This is still 8-year-old device, and I think it's at the in the I don't know, autumn of or winter of its life. Yeah, A0, A9, and A5, 9.5. Yeah, back to the MPU. And back to this 9.5. 9.5 swapped. Yeah, and okay, approved. Yeah, I'm not sure if I pronounce your name, Bo. I hope. Thank you for your, let's say, poke 2 weeks or 3 weeks ago. You mentioned that probably I should rotate the DDR module again. And at the beginning, it seems like a nonsense to me, because in the previous shows, I had rotated it like 3 times. But yes, last week or the week before I rotated the module because it gave me the, let's say, better initial conditions. So thank you. Your comment was, let's say, the last drop to the bowl of my yeah, you name it. What's the length? So 2 short, 2 bloody short. Here must be length tuning pattern as well. Yeah. Okay, let me play with this. Or not. Thank you. Yeah, thank you. Okay, so probably this way. Probably this way, and let's make a fast check of the length because it seems still too short. My calculator is running. 20, that's bad. 25. Okay, so we have to go crazy. '24 still. Yeah. We have to length tune significantly, but we have some space in here. That's good. And it means A2 and RASN must be swapped. A2, RASN neighboring signals must be swapped. Approved. Okay. Yeah, it's like 25, 28. Okay, not so bad. Not so bad. We have some space. But this one, yeah, 29. Yeah. We have to go closer to 34, which is the central. Yeah, 34. It's probably too long, but 33, I think 32.5 is quite realistic. So we have to continue with this one. Yeah, it will be length tuned, but I'm pretty sure it will work. We have some space for it. Yeah. What else? 2 more. something is wrong. Because there are 3 tracks and only 2 of them are here. So I missed something. What? Wait. What's wrong? Oh, this one. I'm stupid. It must happen all the time. Okay. What else? Okay, this is the working one. Yeah, the rest. Okay, so one is missing. Okay, the top one. Yeah, I think nothing crazy is happening, because still this signal would be too short. Yeah, it's the draft routing, so please forget the imperfections or yeah, this signal must be heavily length tuned. Maybe not. Yeah, I will use this one. RASN and A9. First here. Yes. Approved. Okay. The length is now 26. Yeah, but we have some space to make it longer. 28 maybe now, 26, 27. Okay, okay, fine. Not a biggie. A2, it works. But I will go I don't know what's better. I'm thinking about the reset, because even the reset must be connected. Yeah. Yeah. Okay, let's finish these. Okay, understand. Okay, this one. A9, A13. Neighborings. Okay, approved. The grid doesn't work as we need, but yeah, 24, 29. Okay, not so bad. I expected worse. Much worse. So 2 more. This one, A13. Oh, 3 more. Here, this one. This one is yeah, we'll see. We have some space still. Oh, now the reset. Now the reset, and it violates. Why? Okay. What's the length? 26. Okay. Yeah. Will be heavily prolonged. Now the reset. I'm a little concerned with the reset signal. Okay. So what are our chances? I have to approach the area because my imagination is getting short in such a complex scenario. Okay, so we need to get this one here. Okay. Of course, we can use the bottom layer signal. It's a static signal. It doesn't need to be here, but yeah, there is some space, and why not use it? If we swap these two, A7 and A13, then there will be this area, but how to go around? I don't know if it doesn't make if it makes sense what I'm doing. Yeah, I want to put this via here, but I think it's not possible. Yeah, not enough space. What I need to do is move this one. Yes. But what with this this via makes same issues. Yeah, there is no extra space. No. We should go here. Yeah, and then maybe here, if we make some space for the via here, yeah, it's like bigger work, but I think it maybe we don't need this via at all. Yeah. We will see. Okay, so I need to swap A7 and A9. No, A7 and A13. So A7 and A13. Okay. 713. Okay, approved. Oh, let me check. I don't know. F20. No, reset is fixed, unfortunately. So can't. I will do it. This will work. Okay, and the reset is here. I think it's good. It's a half loop around these signals, but it's a slow signal, static signal. It will work. Okay, so we have the CK enable, which is here. We don't need the VIA at all. Oh, but maybe we do, because the layer is empty, and I can use the top layer signals to connect the decoupling capacitors comfortably. Yes. Draft routing, but it works. Okay, so all the blue ones are connected. Now we have to length tune the shorter ones, the short ones. Recapitulation. Again, we said that the clock is 34.4, which is center of our interval, and we must length tune all the signals to that length with some tolerance of plus minus 3.5. So let's check them. Let's check them all. 33. I can use the inspector. No, here. The only issue is that it takes too much space on the screen and can't be easily hidden. AC signals here. A, C, no. Here. No, this one. BAs, S, this one's. Okay. Length is from 30, 34, 37. Okay. There are some long, but not so long. Even the CKE is within the range, which makes me happy. 26 is definitely short. Highlight selected net. This one, yes. Yeah. This obviously is the shortest ones because it comes from. Yeah. I can see that I should have go, not here, but in this group. to place it somewhere here, and I didn't need to make the length tune patterns, but it would mean that all the group should be relocated, which is something I don't want to do. So I will start with this one. Let's make it 34. And let's see what's possible. Yeah, not bad. But I don't know if it didn't take so much space. We'll see. This one, 29, we need 34, single-sided. Ideally, it should use the same period, but probably not possible in KiCad. This is plus minus of the same length. Not. Okay, now anyway, I will keep it locked. It avoids accidental selection of this. Maximum amplitude, let's say 4. Yeah, maybe. Yeah. Yeah, it works, but each ending needs manual, like, perfection. Okay, what else? 29, let's move it a little bit upward. And I want to use the same 0.4 maximum amplitude, which if it works, I would change the global settings for the future. a little bit longer here, and it worked. So board setup default, not defaults, length tuning profiles, length tuning patterns here. Here, maximum amplitude is 044. Yes. Again, 34 and single-sided. Anyway, can I check the single-sided? Yes. So it will save me one click and like 3 keyboard presses, which is not good, not bad. Yeah. This one will be tough. Let's try it. We will see. We have like 2 segments, so it will work. Yes, and here. No. Why not? It's such a lovely spot. maybe. Okay, maybe. I think I can go closer. Yes. $29. What else? 31, 32. And these ones are already fine. Okay, so like 3 more, 4 more. 3 more. Let's try this. Yes. Now here. Now this one. Yeah. Okay. This one, 32, and we are getting closer. I think this one is the last one to be tuned. Yeah, within 2 rounds. Okay, we are 150, not 150, 1 hour 50 in the show. And I don't know. Either I will take a break for half a minute or minute, or conclude the session. I'm in the flow, so I will continue. I'm back in the second, or like 30. I'm back, and let's continue for like 20 minutes. Yeah, I should have keep the browser open with my Fedival course, but I will do it at the end of the session. Oh, what's happening here? Ah. Okay. So to do is I will keep it. It's within the tolerance. Yeah. The reason I'm doing this is that there are some tracks at the bottom which are 36 and 3 of them 36, and I want to make them shorter. So in order to do that, I have to move the entire thing or reshape the entire thing to achieve shorter tracks distances. Yes, think like this. My target value is 34. The closer to the 34, the better. But everything has some tolerance. Yeah, this will make the situation worse. Yes. Yeah, not bad. Why I am targeting 34 and not 34.4? I don't know. 34 was easier to remember. It's fine. Yeah, almost 34. Fine. Now I think these tracks says yes 36. These must be shortened, and I hope it will happen by making the corners more sharp because of the Pythagoras triangle or law. Almost perfect. Where it relates? Here. Okay. No problem. Or not enough space. Yeah, stay the same. I will keep it. Yes, it's good. I think this will be too short as well. Yeah. matter. What's this? Set to 3.6. I will keep it. Yeah, good enough. Okay, 34. Good. Yeah. Yeah, I will change it because I forget here to improve the tracks. How much? Yeah, I will delete it. Start over. I don't like it. Let's try here. Yeah, maybe better. What about the clocks? 34.4 must be kept. Now we are like 32. Yes. .4, double-sided. Let's rock and roll. Oh, let's do it single-sided as well. Here are some vias which makes the situation worse. Let's try it. This is it. Oof. I don't know. I don't know. Maybe not. Yeah, it looks like, I think it's okay. It's okay. It's a-okay, I think. I will screenshot it for my posts. Yeah, I think it's okay. I like it. What do you think? Not bad. I think we did a good job. Next week we will continue with the routing. As you can see, not so much to be routed, like the port is almost empty. The biggest deal is done, and that's fine. So I will continue with the, probably I will continue with the memory, the decoupling caps, and we need to make a note for our future selves. So this is done, 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 and done. Yeah, so decoupling caps for the memory and another vias and VDD connections. What else? Like regular local routing of the other blocks. Yeah, I think this is enough. By the regular routing, I mean to connect, for instance, this block, the power supplies, yeah, this block, the M2 connector, SD card, or what is it? Yeah, MD card. Because yeah, it will help us to route the long track signals. I usually start with the local blocks to place vias and everything, and then I know where the long haul signals can be routed and where is the areas of the via array, for instance, or yeah, anything. I think fine. I think it's fine. We have good to go with all the other blocks, and it will not take so much time because this DDR thing was a crazy freaking big deal. But we have done it. Thank you. Regarding the courses, you know that I created 2 courses at fedevel.com, 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 for KiCad for Beginners, Essentials of KiCad. You will start with this power supply switcher PCB, 3.5 hours or 4 hours of the course. You will learn how to create symbols, footprints, schematic capture, component placement, PCB layout, importing graphics, everything is there. There is a special promotion from nextpcb.com. If you enroll the course, you will receive a coupon within 30 days after you enroll the course, and there is a special thing. You will get your PCB assembly, so PCB and components, almost for free. Because, or for free, there is a typical price of the PCBA that was stated based on my design. If you use another components or more components, it will get bigger, or if the PCB will be bigger, it will grow higher, the cost will grow higher, but not significantly, I think. So PCB for free, including components, and the makers, the same story, more difficult PCB with all the cool stuff like dual core processor, M2 connectors, dual USB Type-Cs, a bunch of everything is there. And again, a special promotion, nextpcb.com. You will get your board for free. As I remember, the average price of the PCBA was like $100 US. So you will get your assembly for $100 US value for free. If you enroll the course, if you enroll the most cheapest or least expensive one for 69 euros, which is like $75 US, then you will learn a lot and you will get your PCBA of the value of $100 plus minus. So it's a no-brainer in my opinion. And if you know something about KiCad, you can jump into KiCad for Makers. But yeah, it's up to you. If you want to support me, buying the course is one of the ways I prefer. If you don't want, at least hit a like button, drop a comment, or tune in next week. That will make me happy again as well. So thank you for being here. Our layout is I think nice looking. What do you think? Let me know in the comments. See you next week. Bye.